Okay, so for today, we are going to be using the relationships we established over the last couple of days about if you have parallel lines cut by a transversal, you have numerical relationships between those angles. And so we're going to be using those in some proofs. Don't scream too hard. I really actually think you're going to do well with this. So what I want you to recall is this. If you see like linear pairs in a diagram, you know you have to call them out and put it in your proof. You have to say, oh, angle 3 and 4 form a linear pair. And the reason is by definition of their linear pair. Now, if you see vertical angles, you do the same thing. And then today we're going to be using that when you're like, oh, I see alternate interior angles. You say angle 4 and 5 are alternate interior angles. Why? Definition of alternate interior angles. So that concept is going to be enlarged a bit, okay? But you're used to it. You've done that in the previous chapter. And so this is kind of your chance to say, okay, I can do that. And even if you didn't do it perfectly in the previous chapter, I really think this is going to be your time. And so moving forward on this, if you have defined them to be a linear pair, you know your next step in the proof is to say, hey, according to the linear pair theorem, if I have linear pairs, we know that linear pairs are supplementary. Why? The linear pair theorem. And so you'll state linear pairs are those two angles are supplementary. Why? By the linear pair theorem. And so, and then the following one would be that you could state that they add up to be 180 degrees if you so choose, okay, if it makes sense. So let's remember these three steps together that we've used in the past chapter. If you see a set of angles in the diagram that are linear pairs, in the statement you say angle 1 and 2 are linear pairs. Why? The definition of linear pairs. Then you would state in the next step, angle 1 and 2 or whatever angle you're talking about are going to be supplementary. I don't know why I switched numbers here, but anyway, if those angles are linear pairs, then you can state that they are supplementary. Why? By the linear pair theorem. Okay. And obviously in your proof that you would have your angles match, but, and then if you want to, if it makes sense in your proof, you could say, the measure of angle 3 plus the measure of angle 4 equals 180 degrees. How come? Definition of supplementary. So this is, a sometimes thing that happens. But that step of three things, two or three things, is consistently something that we use in proofs. And we did that, with vertical angles as well. If you said angle 1 and 3 are vertical angles, by definition, your next step could be angle 1 and 2 are congruent. Why? The vertical angles there. So your step 1 would be define them to be, by definition, they're vertical angles. Your step 2 would be that they're congruent by the vertical angles theorem. And we could actually, perhaps even depending on the proof, you could say the measure of angle 1 equals the measure of angle 2. Why? If things are congruent, we know that they're equal in size by the definition of congruent angles, okay? And so we use that too. So again, the step 3 may or may not be used in that problem, but I want you to remember the first two go together, okay? Step 3, you have to decide, does it make sense for that question? So we will keep practicing, hopefully a lot of time in class so that you guys can work together. Because some things are a little weird, but I know you're going to get better and better and better this chapter. So for this chapter's proofs, the same 3 steps will occur. Step 1, okay, you have to say the lines are parallel, okay? It probably is a given, okay? The lines are parallel. And the thing is, the if-then statement for these angles to be in a relationship is if the lines are parallel, okay? And if they are, you state what kind of angles they are by definition of that kind of angle. So you might have to say, okay, these lines are parallel, step 1. Step 2 is angle 2 and 3. 1 and 2 are going to be blah, blah, blah. You might say corresponding angles. You might say alternate interior angles, etc. by definition. And then your next step would be, your third step would be that therefore, angles 1 and 2 are going to be, and you might say congruent, you might say supplementary, depending on the relationship. Remember, same set interior are going to be supplementary. If they're corresponding, they're going to be congruent, etc. And so you have to say, the lines are parallel, then you're going to state what what their vocabulary relationship is. And then the third thing would be the theorem that binds them together. And so these three things will always go together. There may be a fourth step in this type of proof. Okay. That means the measure of angle 3 is equal to the measure of angle 4. Okay. Or, and by definition of congruent angles. So you might have a step 4 in this situation, because in this type of proof, you need parallel as your step 1. Step 2 is the vocab of calling them a name. Step 3 is going to be saying that means they're congruent or supplementary by the theorem. And then step 4 might be the optional step. And so we'll practice that. A couple more features that you need to remember from last chapter would be the reflexive property if an angle is congruent to itself, okay? And then symmetric property of congruence is going to be if an angle 1 is congruent to 2, then 2 will be congruent to 1. And the transitive property, we like that 1 is congruent to 2. If 2 is congruent to 3, then therefore 1 and 3 have to be congruent as well. And then also remember equality. Who can be equal? Measurements, okay? People aren't equal. Their measurements could be equal, okay? And so measure of angle A equals the measure of angle B. You could also say the length of angle segment AB is equal to the length of B to C. So lengths can be equal, measurements can be equal, okay? The measure of angle C can equal a number, okay? Congruence, shapes can be congruent to each other, okay? So shapes can be congruent. Oh, I don't know how I crossed that out, but let's erase it. Okay, so shapes can be congruent. Okay, you could say 2 triangles are congruent. You could say 2 angles are congruent. You could say 2 segments are congruent. Shapes can be congruent. That means they're the same shape and size. And then the link between these two will be the definition of congruent angles or the definition of congruent segments. If 2 angles are congruent, we know that their measures will be equal numerically. Same with this. If 2 segments are congruent, then their links will be equal as well. Okay, so if AB is congruent to BC segment, then the length from A to B equals the length from B to C. So the definition of congruent angles or the definition of congruent segments will help us make that bridge between equality and congruence. Okay, so in a proof, okay, and again, don't lose your mind. It's going to be okay. The thing is that we are given that line L and line M are parallel to each other, okay? And then we're also given that line M is parallel to line N, okay? Now, could we show that line L and N are parallel to each other? Yes, we could. We're going to take in a different approach, okay? We're going to actually use, let me show you what we're trying to actually prove that angle 1 and angle 12 are going to be congruent to each other. And if we knew that all 3 lines are parallel, or we went that direction, then we could say, well, yeah, by alternate exterior angles, therefore 1 and 12 will be congruent. But instead of going that direction, because we want to practice doing like the angle stuff, we're going to kind of use some intermediate angles and say, okay, we know 1 is congruent to something else and something else is congruent to 12. So therefore 1 and 12 have to be congruent. So we're, in a sense, kind of walking past, like circumnavigating, going around the principle of saying, let's just talk about the lines being parallel to each other and then going straight to alternate exterior angles. Instead, we're going to say, we're going to go a roundabout fashion, which is fine. It's good for us to practice, talking about the angles that are related to each other in this proof. So line L and M are parallel by given, okay? And we know that right up here, these 2 lines are parallel to each other. And then we're going to use some angle relationships based on those 2 parallel lines to start out. Again, our goal is to get from 1 and 12. Okay, we're going to get to that in a minute. So angle 1 and 8, how would you call 1 and 8? Okay, between these 2 parallel lines here, those are alternate exterior angles. So alternate exterior angles. How do we know that they're alternate exterior? By definition of alternate exterior. Again, naming something an angle in a relationship is by definition. Okay, because the lines are parallel and they're alternate exterior angles, we can say angle 1 and 8 are congruent. Why? The alternate exterior angles theorem. Okay, so we got 1 and 8 going to be congruent. Pardon me as I write with my finger because my pen doesn't work. Okay, so the next thing that they gave us is that line M and N are parallel. How do we know that? It's given. Okay, so we know these two bottom angles are parallel to each other. And we're going to focus on relationship. Again, our goal is to get from 1 to 12. So what do you think we're going to do? Well, 8 and 12, how are they related together? Well, they are corresponding. How do we call them that? Well, definition of corresponding. Okay. And then because they're corresponding, what do we know? The lines are parallel. We said that. The angles are corresponding. Therefore, the two angles are congruent. Why? The corresponding angles postulate. Okay. And then therefore, angle 1 and 12 are congruent. How do you even get there? Well, let's check it out. What did we do? We did some fancy math. We said that 1 and 8 are congruent. 8 and 12 are congruent. Okay. Well, then what do we know? 1 and 12 are congruent. Why? The transitive property of congruence. Okay. So we could have gone other routes, but we chose to say to get from 1 and 12, we linked together relationships between the first two parallel lines. We linked together relationships between the second two parallel lines. We said as a result, the outer two angles have to be congruent to each other. All right, so let's look at our last proof. In this last proof, it's very long, but it's going to be fine. Okay, so the way that we do this would be here. They give us that line M and N are parallel. Again, if we're going to be talking about numerical relationships between angles that are formed by lines with a transversal, the lines should be parallel. Otherwise, it's a little tricky to do proofs with this. So we're going to focus on that kind of relationship. And so we know that line M and N are parallel to each other, and it's labeled with those little arrowheads. So let's write down right here for our given that M and N are parallel to each other. I'm going to just put arrows above them and put a parallel line between it. Okay. So M and N are parallel to each other by given. And we also know that line L is a transversal. Okay. My handwriting's great. And so then what we want to do, our goal is to prove, watch this. Okay. Our goal is to prove that angle 1 and 2 are supplementary to each other. Okay. We also want to prove that angle 3 and angle 4 are supplementary to each other. Well, wait a minute. We know that they are supplementary because they're same side interior, right? What's wrong with people? Well, what we're hoping to do is, remember, that's a same side interior angles theorem, right? And a theorem can be proven. What do you mean? If you're in a court of law, you have to prove that somebody is innocent or guilty, right? Even if it's already true, okay? So if we know there's a relationship between angle 3 and 4 that makes them supplementary, we could use that if we're doing a different proof. We could use it absolutely because we know it's true. But what we're going to do is we're going to say, can you show it a different way? Okay, that's what we're doing is we're proving a theorem that already is true by showing it from a different perspective or different direction. So we do know it's true. Okay, we're not trying to prove a lie. We're trying to prove something that's actually true. And again, we're just demonstrating or showing it, from a different perspective than just saying, yeah, they're same side interior. Okay, so watch us go from another perspective because there's a lot of relationships, so it's really not that hard to say, let's show it from a different perspective here. Okay, so again, goal 1 and 2, of course, are supplementary and 3 and 4 are supplementary. So what do we know? Well, we know that angle 1 and 3 are a linear pair. Okay, so again, we want to form a relationship between 1, 2, 3, and 4-ish. Okay, so 1 and 3 form a linear pair, and 2 and 4 also form a linear pair, don't they? Okay, do you see those guys? How do they do that? How do you call them a linear pair? By definition of the linear pair. Okay, cute. But if they're a linear pair, what do we know about those angles? We know that 1 and 3, and then also 2 and 4 will be supplementary. Why? The linear pair theorem. Okay, so we called them a linear pair. We use the fact that they are a linear pair to say that means they're supplementary. Occasionally in that linear pair theorem or vertical angles theorem, we go one more step and we are going to take that step. That means that the measure of angle 1 plus the measure of angle 3 equals what? Numerically 180 degrees. How do we know that? Definition of supplementary. If those angles are supplementary to each other, that means that when you add their numerical values together, you get 180 degrees. Okay, so we said 1 and 3 are linear pairs, they're supplementary, and then also 180 degrees. Okay, the next thing we want to do is to link together angles, some more angles. Okay, what about angle 1 and 4? How are angles 1 and 4 related to each other? Well, they're alternate interior. Okay, how come? Definition of alternate interior. Okay, and if we have alternate interior angles, okay, again, we're talking about angle 1 and 4. So 1 with 4, they're alternate interior angles, and then also 3 with 2. We know that those two angles will be congruent. Why? Alternate interior angles theorem. Okay, so we link together 1 with 4 and then 3 with 2 by alternate interior angles theorem. And then we're going to go one more step. So we know they're parallel. We know they're alternate interior angles. We know that means that they're congruent. And then if two angles are congruent, we know their measurements are equal in size. So what we're going to do is say, guess what? The measure of angle 1 equals the measure of angle 4 by the definition of congruent angles. Okay, if angles are congruent, they will be equal in size and vice versa. Okay, then the next thing is we know that 1 and 3, we've talked about connecting 1 with 4. Now we want to make the jump to say, let's get back to our original goal. We want 1 and 2 to be supplementary. Okay, so we're going to link together the last two things we've said. We're going to link together this right here. Angle 1 and 3 are going to be 180 degrees, same with 2 and 4. We're going to link that with these situations where 2 and 3 are congruent, are equal in sizes, as well as 1 and 4. So again, we can put this together by substitution. So if we know that 1 plus 3 make 180 degrees, but 3 and 2 are equal, well, then we know that the measure of angle 1 plus the measure of angle 2, I should put an M there, but I don't know if I can make it. Okay, so the measure of angle 2 makes 180. And then also if we know that 2 and 4 make 180, well, that means that the angle 3 plus angle 4 equals 180 by substitution, okay? And then that means if you know that 1 and 2 make 180, what do we know about her? Well, that she's supplementary. Okay, why? By definition of supplementary. And that was our goal, is to say, we know, we want to show, okay, the same side interior angles theorem by coming at it from a different direction. And we did. Okay, so we are going to use these relationships. And again, those 3 or 4 step principles where it's like, say it's parallel, say that they're define what angle they are, what relationship they have. And sometimes we're going to go to say, okay, that means that they're going to be equal in size. So do your best on your homework and let's talk about it tomorrow. Thanks so much. Bye.